Well, if you think you're sleepy just because you're still trying to adjust to daylight savings time, imagine having to see 16 sunrises a day. That can really turn your sleep off and throw it off, and the lack of sleep can really affect our health and our overall job performance. That's why it is vital to understand the sleep patterns in astronauts, because they're in such high performance jobs and they really need a good night's sleep.
We like to say that sleep is the third pillar of health. So not only is diet and exercise important, but also sleep. And that's not just for your performance, but also for health reasons. We know that when people sleep 6 hours or less a night, they're more likely to be obese, have diabetes, have adverse cardiovascular outcomes. So we're interested in learning about how much astronauts sleep in space, and if they're not getting enough sleep, what countermeasures are available to help promote sleep in space.
And then some people like to tie themselves, but I actually don't. I really like to just float when I'm sleeping, so that's really it. I would turn the light off and good night.
We really don't think about it, but I guess it's a little awkward sleeping in space, right?
Right. It's still a pretty harsh environment for sleep on the International Space Station. Astronauts have told us that sometimes it's too hot or too cold or too noisy.
This is how we sleep aboard the space station. This is called a crew quarters or a sleep station, and this is where I sleep every night.
They also have a light-dark cycle that is 90 minutes long rather than the 24-hour light-dark cycle we have on Earth. And so that can, if light is insufficiently intense or mistimed, then you can have circadian misalignment.
And so what does that mean?
So normally our sleep-wake schedule is synchronized to the Earth's light-dark cycle. And so when we are awake during the day and sleep at night, it's easy to sleep. Our body wants us to sleep, and we go to sleep at night. On the space station, sometimes they have abrupt changes in their sleep-wake cycle that causes their circadian system to become misaligned. We know from our previous work on the space station that on those times when the circadian system is misaligned, they sleep about an hour less, and they use more sleep-promoting medications. So now we're really curious about how sleep is affected during the second 6 months of a year-long mission. Will sleep get better? Will it get worse? We're just collecting those data right now.
How do you collect the data? What is it?
We use an actigraph to collect the data. It's similar to what you see commercially available, a Fitbit or a Jawbone or one of those. This actigraph is a bit hardier, and it's scientifically validated with algorithms that estimate sleep. It also gives us light exposure information, and we can feed that sleep and light information into a mathematical model that estimates circadian phase. So we know whether the astronaut is aligned or misaligned circadianly. The ultimate goal of the study is to find ways for crew members to sleep better in space, to be able to obtain more sleep. Just like we study here on Earth, different occupations that have unusual work hours. And we like to see how their sleep is affected, how their alertness, performance, and safety outcomes are affected by their work hours. So we've studied police officers and firefighters, federal air marshals, resident physicians, even the mission controllers here at NASA, and evaluated fatigue countermeasures to keep them more alert during the work and enable them to sleep better. The information we collect today will be really important for future one-year missions or even longer missions, because being able to obtain adequate sleep each night on these exploration missions is going to be very important for their health and safety and performance.